Hello there, Mr. Sutton here, bringing you the 2022 MCAS solutions. On this problem, we're just trying to find the solution for this equation. So a good first step here would be to simplify the left side by distributing this 3. So we'll have 3x, and then 3 times 5 gives us 15. And then the right side of the equation still is what it is. Now, since we just have x to the first power, there's no x squared or anything, this one's going to be easiest to solve if we just get all the x's on one side and the non-x's, the constants, on the other side. It doesn't really matter which way we go, but I'm choosing to move the x's over to the left side just because that's how I'm used to doing it. So if I do 3x minus this 5x here, that'll give me a negative 2x over on the left. And if I subtract 15 from both sides, negative 7 minus 15 is negative 22. Now I just need to divide by negative 2 to undo the multiplication by negative 2. So negative 22 divided by negative 2 gives me 11, and that's my answer, choice D. On this problem, we have two rental car companies, and they have a fixed fee for renting the car, which they detail here, along with the additional amount for each mile that the car is driven. And this is kind of a standard package, although I don't know that these prices reflect current prices, but hey, whatever. So we want to create an equation for each company and basically just drag and drop these possible numbers into the equation for each company. These equations are telling us how much it's going to cost total to rent the car, including both the fixed fee and the per mile charge. So the way that this is going to work, we notice that these boxes, one of the numbers is going to be multiplied by x, and the other number is just going to be kind of a constant that's being added on after the fact. So for company A, since we're doing 10 cents per mile, we're going to drag the 0.10 into this times x box right here, because x is the number of miles, so every mile we're multiplying that by 0.10. And then the fixed fee is what we're adding on after here. That'll be this 25. We're going to do the same thing for company B. The per mile charge there was 20 cents, so we'll do a 0.20 times the x here. And then we're going to do the 15 being added on here. On this one, we have these similar triangles, and basically we want to find the value of this z side for the bigger of the two triangles. And we have to do all this without a calculator too, which kind of makes this one interesting. So because these triangles are similar, that means that their corresponding sides, like 11.2 and 5.6, they're in a proportion. So there's a ratio going on, and we can set up a proportion. For example, I can say 11.2 over z, or z over 11.2, either of those, equals the same sort of setup with the other triangle. So if I did smaller side over hypotenuse, I could say 2.9 over 5.6 for this other triangle. And now, since we have two fractions with an equals, we can solve this proportion using cross-multiplying. But again, we're not allowed to use a calculator on this one, so we have to be a little bit clever about how we're going to do this if we use this current setup. So I've got 5.6 times z, and then I have 11.2 times 2.9. I'm not going to use long multiplication to do this, although I could, because it turns out I don't have to. To get z by itself, at some point I have to divide by 5.6. Now, that means I have to divide one of the things over here by 5.6, not both of them. Between the two of them, I would rather divide 11.2 by 5.6, because that has a value of exactly 2. So I can write z equals 2 times 2.9, because again, I divided 11.2 by 5.6. And I can do 2 times 2.9 without a calculator. So that would be, it's like 2 times 29 with a decimal in there. So that would be 5.8 then. And if I wasn't really sure, I do have an answer choice that helps me out here. So that's choice C. For this problem, we're given this 8x squared plus 16x plus 24 expression, and we want to know which of these answer choices is equivalent to this. So if you look at all the answer choices, it kind of gives you a hint as to what you need to do with the original. All of them have this 8 outside of parentheses of one type or another. So it looks like what they did was factor out an 8 from this expression. So let's see what happens if we do that on our own without really looking at the answer choices. So we have 8 coming out of 8x squared. Now, when you factor out something, you're dividing everything by whatever you're factoring out, and then putting the leftovers in a parentheses next to it. So you're basically unmultiplying. So 8x squared divided by 8 is x squared. 16x divided by 8 is going to be 2x. And then 24 divided by 8 gives us a plus 3 in there. And that matches up with choice C. Now, if you weren't sure, you could have actually just distributed 8 in all these different situations to see what would have given you what you started with. For this problem, we're given 5 terms of an arithmetic sequence, and we want to know which of these expressions gives us the nth term of the sequence. So if you know nothing about arithmetic sequences, you still could do this problem. You just have to start plugging 1, 2, 3, 4, and 5 into these expressions to see what gives you this list of numbers here. For example, when I plug 1 into all of these things, I can already eliminate some that are not going to give me 2 right off the bat. Like 3 times 1 is not 2, 4 times 1 is not 2, 3 times 1 minus 1, and 4 times 1 minus 1. Those both give you 2, so you'd have to plug in 2 then, and then possibly 3 to narrow it down between choices C and D. But let's pretend that this wasn't multiple choice. How could I do this just legitimately using actual math that has something to do with this? So the formula for an arithmetic sequence, you're going to have A1, that's your starting term, plus the common difference D, times n minus 1. This is our go-to arithmetic formula, although it's not on the reference sheet. So in this case, our A1, that's our starting term, that's this 2 right here. And then our common difference, that's going to be what I have to add each time to get the next term. Or I can do one term subtracting the term before it. So that's 4 that we're adding each time. And then I have to multiply that by the number of terms minus 1 to figure out the value of the nth term. And this n minus 1 is because you've already used up one of the terms with this 2 right here being added in. So this formula right here is not represented in our answer choices. That means you have to simplify this a little bit to match it with an answer choice. You can distribute this 4 to the n and the minus 1. So that's a 2 plus 4n minus 4. And then I can combine the 2 and the negative 4 to get negative 2. So then 4n minus 2, choice D, that's another way you could have gotten that answer. There we go, choice D. For the next couple problems, we're using this graph here that models the relationship between the time that a car has been driving for on the x-axis and the distance the car has driven in miles on the y-axis. And our first part, part A, they just want to know what this point that they gave us, 6, 300, actually represents. So there's 2 things going on. We have the input and the output. The input is the time that we've driven. The output is the distance we've gone. So we can say here at 6 hours, this car has driven 300 miles. For this part of the problem, based on the graph, they want to know the average speed of the car and then show or explain how we got the answer. So the average speed of the car is just going to be the slope. So we could use our slope formula, y2 minus y1 over x2 minus x1. The thing is, our starting point here is 0, 0. So really for any point on this graph, you really just need to do any y value that goes with an x value divided by the x value it goes with. So for this one, we can just do 300 over 6, and that will give us our average speed, which if we divide that is going to be 50 miles per hour. For the next part, we have another car traveling a distance of 209 miles in 5 hours and 6 minutes. We want to estimate the average speed of that car. Key word here, estimate, because this is still in the no calculator section. So although we could try to do 209 divided by whatever 5 hours and 6 minutes looks like as a decimal, but we don't really need to do that much work. So let's estimate each of these values. Instead of using 209, I'm going to use 200 miles. And instead of using 5 hours and 6 minutes, I'm just going to round that off to 5 hours. So now if I do 200 miles divided by 5 hours, that's going to give me 40 miles per hour. For the last part of this problem, we have another car with an average speed now of 61 miles per hour, traveling for 8 hours and 28 minutes, and we want the total distance the car traveled. So again, we're going to want to round off these numbers. One other thing that's a little bit different here is now we're not asking for the speed, we're given the speed, and we want the distance. So to get that, we just have to multiply the average speed by the number of hours. But let's round these off first. So instead of 61 miles, of course, I'm going to use 60 miles per hour. And now this other one's a little bit iffy what they really want here, because you could round this down to 8 hours, but that's so close to 8.5 hours that I'm going to be ambitious, and I'm going to round this off to 8.5 hours. I'm pretty confident that I can deal with this measly 0.5. I mean, I don't like dealing with fractions and decimals in general, but I think I can handle like a halfway sort of deal. So, multiplying these two things together to get my distance, 60 times 8.5, without a calculator. So let me break this up here. 60 and 8, that's going to be 48 with a 0, so 480. But now I have to multiply by a 0.5 as well. So half of 60 is 30. 480 plus 30 gives me an estimate of 510 miles. For this problem, we have a demonstration of some kind of proof. We have a triangle being folded up into a rectangle here, and we want to know which property of triangles is best illustrated by all this. So taking a look back here in the triangle, these angles 1, 2, and 3, you'll notice these are all the interior angles of a triangle. And we're thinking interior, exterior kind of thing because our drop-down menu here talks about those. These are all interior angles. Now we know that the interior angles of a triangle add up to 180. And this actually demonstrates that because when you fold these triangles over here, you see that these angles are now all forming a straight line, and we know that the angles of a line must add up to 180. So just looking at our drop-down menu, we need to pick interior angles. The sum of the interior angles of a triangle is equal to 180. On this problem, we have a system of inequalities that we're supposed to graph. Now, the good news is they've actually given us this in multiple choice form. So let's see if we can narrow this down by looking at the direction of these inequalities. These are both y greater than, which means that we're going to be shading above whatever line we choose to draw. So taking a look for a graph in which I'm shading above both of the lines, we're doing that in choice A. We're not doing that in choice B. We're underneath this one line here. Choice C, we're also under one of the lines. Choice D, we're under both of the lines. So choice A is actually the only one that matches these inequalities. On this problem, we have some intersecting lines here, a transversal going through some parallel lines, and we've got a whole bunch of angles represented. We want to see, based on this diagram, which of these equations is not always true. So taking a look at one of these at a time, we have x plus 10 and 3x plus 66. If we add those, we get 180. So on our diagram, that's these two angles right here. Now these form a linear pair, and we know that a linear pair always adds up to 180. They're supplementary. So this is always going to be true. So that's not the answer we want because we want the one that's not always true. Moving on to choice D, we have 4x plus 40. And if we add that with x plus 10, they're saying that that adds up to 180. Well, we don't know maybe about these types of angles. These don't really have a good name for this relationship. However, this angle right here next to the 4x plus 40 is a corresponding angle to this x plus 10. It's going to be the same angle. Since 4x plus 40 is a linear pair with this corresponding angle that we already showed was going to be supplementary, this is going to be true. So these two angles are also going to add up to 180 for sure. Moving on to 3x plus 66 equals 4x plus 40. That's, let's see, this angle here and this angle up here. Now these angles are alternate exterior angles. And there is a proof with a theorem that says that those are always going to be true, congruent. So this is a true statement. Those are always going to be congruent. Well, by process of elimination, it's looking like choice D, but let's take a closer look at it. We were saying x plus 10 and 4x plus 40 equal each other. Well, we already saw that those, at the very least, added up to 180. Now, if these add up to 180, the only way that they could possibly equal each other is if they're both 90. But they don't necessarily have to both be 90. In fact, there may be no value of x that's going to make these equal 90 at the same time, at least. So this is, since it's at least not always true, we're going to say this is false, and then choice D is the answer that we need here. For this problem, we want to know which expression is equivalent to this one. Literally, all we have to do here is distribute this -2. So just do it carefully. So we're going to have 7 minus 8x, and then -2 times -3y. Negative and negative is a positive, 6y. And looking at our answer choices, we have 7 minus 8x. We have that in all the answer choices. We just need this plus 6y, which is only in answer choice A. For this problem, we're going to use this volume formula for a cylinder for a couple problems. First problem, they want us to rearrange this equation to solve for h. Well, to get h by itself, since it's being multiplied by pi and r squared, we're just going to divide by pi and divide by r squared. So then we'll just have to write h equals v over pi r squared, that whole thing in the denominator. And for this part of the problem, now we are rearranging to solve for the radius, r. This is going to take at least 2 steps. So first, I need to get r squared by itself. I can't do it all in one shot. So if I divide both sides by pi and h, I can get r squared alone. So I can write r squared equals v over pi h. And now to unsquare r, I have to take the square root of both sides. So I can write r equals the square root of this whole thing, v over pi h. And normally when you take the square root of an equation, you need a plus or minus. We don't need the plus or minus here. There's only a positive root because the radius is always going to be positive, so we don't need to write a negative. On this problem, we basically need to simplify this expression here. So using our exponent rules, when we have things inside a parentheses with an exponent outside, if everything inside is being multiplied or divided, we can multiply the exponents in here by this outer exponent. So this x to the third, this is really x to the 3 times 4, or x to the 12. And we have y to the 5 times 4, so y to the 20. And for this next one, we've got x to the 3 times -2, so that's -6, and y times 2 to the -2, or y times 2, y to the 2 times -2, a lot of 2's in there, so that's -4. Now, normally I would say we're going to turn these negative exponents into 1 over each of these things to a positive exponent, but before we bother doing all that, let's just multiply all this together and see if the negatives take care of themselves. When I'm multiplying bases together, the exponents get added together. So this is going to be x to the 12 plus -6, or 12 minus 6, or just x to the 6. Here we've got y to the 20 plus -4, so that's going to be y to the 16. And I have no negative exponents, so I'm actually all set with this problem. 6 and 16 are the numbers that you would drag and drop into those boxes there. On this problem, which we're doing multiple problems for, we have a student getting a gift card for a coffee shop. They used the card to spend the same amount every day, which seems kind of true to life if you keep getting the same thing, until the value on the card was 0. The function here, f of n, tells us the value of the gift card after n days. Based on this function, now if we're doing part A, what was the original value of the gift card? And how did we get the answer? So the original value is going to be whatever you have on day 0, 0 days. So that's going to be negative 2.5 times 0 plus 75. So we're doing f of 0 here. Negative 2.5 times 0 is just 0. So this whole thing comes out to $75 that we started with on that gift card. For the next part of the problem, we want to know, based on the function, how much money the students spent each day at the coffee shop. So this is a linear function here. This is something in y equals mx plus b form. The slope out of this thing is this negative 2.5. That keeps getting multiplied by the number of days. So since that's our slope, that means that's what our student is losing off their gift card value every day, which is to say they are spending $2.50 each day. For part C of this problem, we want to know the value after 20 days on this gift card. So for this, we just need to do f of 20 because the function already tells us how much is left on there. So this is negative 2.5 times 20 plus 75. And we do have to do this one without a calculator. So negative 2 times 20 would be negative 40. Half of that would be another 10 off, so negative 50 overall there, plus 75. And then that's going to add up to $25. For the last part of this problem, we want to know how many days did it take the remaining value of the gift card to be 0. So basically we're saying now instead of plugging 0 in for n, we're plugging 0 in for f of n. We want the result of this negative 2n, or negative 2.5n plus 75 to be 0. So setting up that equation and solving for n, that'll give us how many days this took. First step, I'm going to subtract 75 to get it over to the other side. Now I need to divide by negative 2.5, and again, we have to do this without a calculator. So the way that I kind of imagine this in my head, I know that negative 2.5 would go into negative 7.5 3 times, and then since I'm going into 75, that's like 10 times that. So that would be a total of 30 times that I would have to do these negative 2.5s. So 30 days then to get our balance down to 0. For the next couple problems, we're using this function, which models retail sales data in the U.S. From 2000 to 2017. So we got to read this carefully because they said in this model, T is the number of years since 2000. So 2000 actually would have a value of 0 if you wanted to find out at exactly 2000 what was the deal here. And then we also have to read here that R is the amount in billions of dollars of retail sales. So our first question, based on the model, what was the amount in billions of dollars of retail sales for the year 2000? Again, since T represents years after 2000, this is a value of 0 for T that we're plugging in. And then we just have to plug 0 into this function. So that's going to be 263.3 plus 11.6 times 0. Which is just going to come out to 263.3. We just have to remember that that's in billions of dollars. For the next part of the problem, they want to know, based on the model, which statement about retail sales from 2000 to 2017 is true. So if you look at all of these different statements, they're saying that sales increased by an average of, and then the only thing different between these choices is what that average is. So in general, when you have a linear model like we have up here, the average increase per year, which is what we're talking about here, is basically just the slope of the function. So if you can figure out the slope of this thing, that tells you the average increase. The slope, since this is in mx plus b kind of form, the slope is going to just be the number that's next to your variable. So that's 11.6 in this case. So that means that our sales are increasing by an average of 11.6 billion per year, which is choice A. On this problem, we're given this segment on the graph, and they want us to describe a transformation that'll give us an image that's parallel to this segment. Okay, so what are our choices here? We can either rotate or reflect our segment, and presumably the reflections are going to be over the x or the y-axis. We can't really rotate over those axes because you can only rotate about a point. And then these rotations could either be 90 degrees or 180 degrees clockwise about the origin. Okay, let's think about the reflections first. I think those are the easiest ones to visualize. So if I reflect this over the x-axis or y-axis, either way, I'm going to be changing the direction that this slope is going. So it's not going to, reflecting this thing is not going to give me a parallel segment because I need to get a segment that has the same slope, not a different one. So that brings us to the rotations. It's going to be one of our rotations here. So for 90 degrees, if I rotate this 90, that is going to change my direction. I'm basically flipping this thing more or less sideways. So I'll have a negative instead of a positive slope. If I rotate 180 degrees, that actually won't change the slope. But if you don't believe me, it's actually pretty quick to demonstrate that. Now, when you rotate something 180 degrees about the origin, it's basically equivalent to flipping it over both the x and the y-axis at the same time. So basically negating the x and the y values. So for g, we would go, let's see here, we would go down to -3 and over 4. So there's the image of g prime. And then for j, instead of -1 comma 6, we would have 1 comma -6, somewhere down here. So drawing this segment, we can see that these are parallel. So let me pick rotation 180 degrees clockwise. For this one, we're given the function of f of x, 3x squared minus 7. We're translating this 4 units down to get g, and we just want you to write g. Okay, so the key on this one is realizing that up-down changes like this one here happen outside the function, and they are exactly what you would expect. So down, we're going to involve doing something that makes things smaller. Up, we would make things bigger. So if I'm going 4 units down, that means I'm going to be subtracting 4 from f of x. I have to do f of x minus 4. Now, they probably want something a little bit more clear than this. I'm not sure that this would be accepted, even though we've already defined what f of x is. Maybe they want you to simplify it. So I can go a little bit further and replace f of x with 3x squared minus 7. And I can then combine the -7 and -4 to get a simplified function for g of 3x squared minus 11. For this problem, we're representing the area of a square with this g squared plus 8g plus 16 expression. And they want to know which of these represents the length of one side of the square. So we know that the area of a square is s squared, sides squared. So I can write s squared equals this whole thing. And then I'm basically just solving for s. Now, to square root this thing is a little bit tricky. It might be helpful if we factor this first and we can see what's really going on. So two numbers that multiply to 16 and add up to 8, that would be 4 and 4. So I can replace this with g plus 4 and g plus 4. And I can rewrite g plus 4 as just g plus 4 quantity squared. Now, if I square root both sides of this, I'm just unsquaring both sides to get s equals g plus 4, which is answer choice C. For this problem, we have to convert this expression into something equivalent. So one good step to doing that is to rewrite this radical n cubed stuff inside here with a fractional exponent. So I can write this as n to the power over the root. The root is an invisible 2 here. It's square root. So this is really n to the 3/2 that I'm raising to the 4th power. And if I'm raising one exponent to another, I'm basically multiplying the exponents according to my exponent rules. So I have to do n to the 3/2 times 4. Well, 3 times 4 is 12, and then 12 divided by 2 gives us 6. So this is really n to the 6th power, which is choice B. The next question on this multi-step problem involves a completely different expression. This is all just one problem, I think, because we had some exponents involved. Otherwise, they had nothing to do with each other. This one, we want an equivalent exponential expression, and there's no multiple choice this time. We have to simplify this and put some numbers in the box. So you can see what they're looking for a final answer. They want some kind of fractional exponent. So let me rewrite these with something a little more helpful. I'm going to rewrite this x as x to the 1, just to be very explicit about what that exponent is. And this other one I can rewrite as x to the 4 over 5. If I multiply these together, I have to add the exponents. So I'm adding 1 and 4/5 together. Now 1 I can rewrite as 5 over 5, just using a fancy form of 1 there. So I've really got x to the 5/5 plus 4/5. This is going to come out to x to the 9 over 5, which is what I can put in my boxes there. For this problem, we're given a line segment on the coordinate plane, and we're rotating point R 180 degrees clockwise around point P, not the origin, point P. This actually makes our lives easier than if we rotated it around the origin, because you're basically, just think of this as like a string or like a clock hand just rotating around. That's pretty much what's happening here. We just want the coordinates of where R ends up. So if I rotate 180 degrees clockwise, that's halfway around a circle, which would bring me right here to this spot, and that's going to be the point 2, 1. On this problem, we're just trying to find the y value in the solution to the system of equations here. So on this one, you've got a few ways you could do this. You could either use elimination or substitution. I'm just going to go with substitution here. So to start things off, I'm going to get y by itself in this first equation. So that's going to be subtracting 3x from both sides. So I have y equals 3 minus 3x. And just to make my life a little bit easier, I don't have to, but I'm going to get y by itself in this other equation because I can. So I'll add 2x to both sides. That's 2x minus 12 over there. Or negative 12 plus 2x, either way. So now wherever I see y, I can replace it with 3 minus 3x. So I'm going to replace the y over here with 3 minus 3x. So that gives me a new equation. 3 minus 3x equals negative 12 plus 2x. And then I'm going to get the numbers on one side and the x's on the other. I'm just going to start by adding 12 over to the left side. It doesn't really matter which way we go here, but that'll give me a 15 over on the left. And if I add the 3x over to the right, that's a 5x over there. Dividing both sides by 5, I've got x equals 3. Now, that's one of the answer choices, but notice it says y equals 3. We wanted the y value, not the x value. So I have to plug this back into one of my equations up here to get the y value. And it doesn't matter which one. I'm just going to use this one over here. Doesn't really matter. So this is going to be y equals 3 minus 3 times 3. Whole bunch of 3's going on. 3 minus 9 gives me negative 6, and that is choice A. This problem was kind of tricky. For one thing, they didn't give you a diagram, they just described it, so you had to kind of figure out what they were talking about. We've got a right triangle. Let's start by drawing one of those, QRS, and we don't know which sides are which just right off the bat, so we have to read a little bit more here. They told us that the hypotenuse was QS. So I want to make sure that I label my hypotenuse with the right letters so that everything else matches up. So I'll put Q down here. It doesn't really matter. But then if I put Q here, I have to put S up here because this is my hypotenuse that I just drew. And then by default, that means that R is this other angle over here, the right angle. Next thing they said, the length of side QR, that's this side, is 1/2 the length of our hypotenuse. I could write x for the hypotenuse and like 1/2 x here, but I don't really like dealing with fractions, so I'm going to make this x, and if this is half the hypotenuse, that means the hypotenuse I can write as 2x. Another reason I did this is that here I recognize a little bit of a relationship here. There's a special right triangle where we have x and 2x as two of the sides, and the other side is x radical 3. That is your 30, 60, 90 right triangle that you have on your reference sheet. Now to figure out the degrees, the measure of angle S, which angle, 30, 60, or 90, is across from the x or s or single variable side? That's always the 30-degree side. So S then must have a measurement of 30 degrees. And then Q would have been your 60 degrees angle, and then that meant R was your 90 degrees, if they wanted to know that, but they just wanted S.